Hi, welcome to the data analysis class. We are going to talk about how to describe a variable in this lecture. There are two parts to this lecture. This is part one. What we will learn today is the following. We'll talk about the difference between probability, which is what we learned over the summer, versus statistics, which is the focus of this course. We'll distinguish population versus sample. We'll talk about what's a variable, and we'll go over some major data types, particularly the distinction between numeric versus categorical variables. We'll also begin to do some technical practice. A lot of our basic calculations and analysis will start on Google Sheets. We'll look at that by looking at the class data set from 2019. We'll download it as a CSV file. We'll talk about what that is. And then we'll load that file into JASP, which is a free software for statistical analysis. If you have not installed at JASP, please follow this link to download the software and install it. In 2019, I created a survey for this course as a way to simulate business data collection. I asked the students a bunch of questions, and these questions can be considered a simulation of data on a bunch of employees or data on a bunch of customers. So you can look at this data set as a way for, let's say that I am a manager and I hired a team of 115 brand new analysts, and 115 was the class size from 2019. And I can use this data set to answer some questions about these analysts. What's a typical analyst like? Who will be our top performers? Are they representative of analysts in general? Who perform better, the beer drinkers or haters? I can also treat the students as simulations of customers. And if we pretend they were customers, then I actually have 115 customer records. Then I can ask the question as maybe a marketing manager. I can ask questions about what's a typical customer like? Who will be the most profitable? Are they representative of customers in general? Who will most likely return, women or men? These are all sort of questions that we can answer using statistics. Some common themes are, what's the population? What's the parameter that Manager Chung is trying to estimate? What is the sample? Identify the variables. How many are there? So these are some of the things that we're going to talk about today. As a technical practice, we're going to begin by looking at the data set. The link to the data set is over here. When you click this link, it'll take you to the Google Sheets file. And then from there, once we see the Google Sheets, we are going to download the class data set into a CSV file. A CSV file looks like this. So we'll turn a spreadsheet into something called comma separated values. You can see that there are actually a lot of commas over here, and the commas are really used instead of the lines to separate the files. So you can see that the data values are simply separated by comma, so that's why it's called CSV. And this is how we will separate the columns when we don't really have the lines. Okay, so the lines are visualizations. At the end of the day, the most basic form of data storage on a computer is a CSV file or comma separated values. And packages like Excel or JSP can read this file and then add lines to form the rows and columns, but that's really just purely for a sort of a user-friendly interface, and it's easy for people to visualize, but at the end of the day, the underlying data is always in this format. So once we have downloaded the CSV file, then we'll load the CSV file into JASP for analysis. So let's take a look. So I just clicked the Google Sheets link, which will take you to the class data demo site. Okay, this demo has a bunch of tabs. The first few tabs are for the summer probability series that you probably have seen. What I need you to do is look for the 2019 class data tab over here. So if it's hidden, when you go to the site, you can always come here and look for it, and you can unhide it simply by checking it, clicking on it. Okay, so this is a fairly big survey I did in 2019, and we collected data from 115, I believe, students, give or take, and probably a few less than that. So this is 110 records. Okay, so all the survey questions, every survey question becomes a column in the spreadsheet. So I want you to kind of look at the size of the spreadsheet, look at how many columns there are, how many rows. I want you to see that rows actually represent the students in this class. Okay, so these are individual cases, and then the columns represent what we call variables. So some of the variables are like, are you a veteran or not? So we get a yes, no kind of answer. Some of them are about football, their preferences, the country they're from. And then some of them are numbers. So I like chocolate. This is a scale of 1 to 5. So you get a number from these people. I also ask them to pick a house, which you probably did already. And then we will get these numbers with decimal values to indicate the number of miles from the Mason School of Business, right? So we have collected, so we have prices. These are very big numbers. And then the mileage is a relatively small number. So we have a variety of different numbers. These are discrete. So the ratings or a number of bedrooms. Okay, so this has to be an integer, meaning that decimal values are not allowed, right? Number of bathrooms. Sometimes, you know, you can say 2.5 and so on, but bedrooms are usually a whole number. Square feet, typing speed, and so on and so forth. So we have all sorts of data that we have collected. And so I want you to explore this data set. Get a feel of different kinds of data, and you can always come here, file, go to download, and then what we need is not Excel. What we need is what we call comma separated values, or CSV file of the current sheet. We're going to download this. Okay, it'll go directly to your download file, and what you can do is you can open up JASP. And then come here, we can open a recent file. Right here is what I downloaded. And I can just click on it. And the file now has been loaded into JASP. Okay, so this is the same file that we saw on Google Sheets, but now it's in a new environment that's called JASP. So JASP will allow you to run analysis very, very quickly. And today we're going to use this descriptives button. So we'll go through each of these buttons. Basically, we'll go through a button every week. We'll cover these buttons and maybe a little bit of machine learning. But you will see, we'll cover frequencies as well. So I guess the only thing that we probably won't do is the factor analysis, but we'll learn about all the other buttons. So this week we'll learn this button. Okay, descriptives. So let's go back to our lecture. And a very important idea is this idea of unit of analysis. And it's really about what each row in the Excel's data set represents. So a row is a case in the sample. So you can see case 1, 2, 3, 4, 5, case 1, 2, 3, 4, 5. And these are different data sets. Okay. But when you look at our class data set, the rows represent a student, which can be, they could be simulations of analysts. So we will say the unit of analysis is an analyst. Or we can also consider them as customers. So if we're doing a customer kind of behavior kind of analysis, then the unit of analysis will be customers. However, it is also possible to construct a data set that is stock prices. Then if each row is a stock, then the unit of analysis is actually a company. And then, for accounting, perhaps you have each record is a transaction, then we would say the unit of analysis of transaction. Okay, so the idea is that you can have a data set and your data set is always rows and columns, and your rows represent these cases, and the nature of these cases is basically your unit of analysis. And you want to make sure that your analysis is structured at a uniform level, right? So you don't want to have some cases that are customers and some cases that are companies. Then you're mixing different kinds of unit of analysis. In a data set, you always want to make sure that your rows represent a single unit of analysis. Okay, so we'll come back to this idea, but I want to emphasize the reason why it's very important to pay attention to your rows is because we'll run into unit of analysis issues later on very quickly. We will also need to make the distinction of theoretical versus empirical probabilities. So over the summer, we have studied probabilities, and usually the probabilities are given to you. So when the probability is known, we call that the theoretical probabilities. So usually, in certain domains, not everything, but in certain domains, we actually have quite well-known probabilities that are relatively accurate, and we will call those theoretical probabilities. So for example, what's the probability that a random person is a male versus female? Well, that's the gender probability, and we actually, without actually having to conduct an experiment or collect any data, we already know from thousands and thousands of years of experience that the population is distributed roughly as 50% female and 50% male. And so that is a theoretical probability that's given to you, and that's relatively accurate, and you don't actually have to collect data on that. You already know that. So these are known probabilities. What's the population? What's the probability out of the population of the United States that you will find someone who's a veteran or military? Well, we actually know the size of the veteran or the military base in the U.S. The Veteran Administration keep track of every single veteran, so they have relatively accurate numbers of these. And so you will be able to calculate very accurately what's the probability of getting a veteran if you pick an American at random. Okay, chocolate companies, food companies, in the food industry, the sweets industry, they probably have done a bazillion research studies on whether people like chocolate, what's the probability, what's the population, what's the how many people actually like chocolate, how many people hate the taste of chocolate. So that if you do your research, you'll probably be able to find the theoretical probability of liking chocolate. Okay, without asking your classmates, without asking customers, you should be able to find a research paper or some statistics that people have already done. If they've surveyed the population many times around the world, we know roughly what's the percentage of the population that likes chocolate. Okay, what's the probability of finding a girlfriend, right? That's interesting. So we actually, do you know what's the probability of finding a girlfriend? we may not actually have a theoretical probability for that, right? So some people try to come up with an equation to try to estimate the theoretical probability, but we actually don't have a very good answer for that because that may vary a lot depending on the person, your location, and so on and so forth. So that is probably something that is very different from the other questions, right? Now, what's empirical probability? Empirical probability is things that you estimate on your own. So instead of going with the theoretical. So theoretically, the gender split is 50-50 in this world. But what's the reality like, right? So look around in your class, right? Look at your classmates. Do we actually have a class that's 50-50 split? Well, we may get 40-60, we may get 30-70. It's probably not 50-50 split, right? So when you actually collect data on the gender distribution of your data set, of your sample, you will find the actual probability of getting a girl versus a boy. And that will be your empirical probability. That empirical probability, that number may be very different from the theoretical probability. And think about the veteran military distribution in our class. If we survey our students, we will probably get a percentage that is different from the theoretical probability that we read from prior research, right? And when I survey the class, what's the probability of getting people who like chocolate versus hate chocolate, that is also an empirical probability. Again, we may, for whatever reason, the Mason School of Business may be attracting chocolate lovers more than any other business school. So we have a higher probability of getting people who like chocolate than other schools or than the general public, right? Then we will get a higher number on the empirical side than the theoretical side, or vice versa, right? So again, the idea is that whatever sample you have at hand, and hopefully you will realize by now that I'm referring to the class as a sample, which is the 115 students, which is it's a good sized class, but it's still a very, very small group of people compared to the world's population or the entire United States. And so the empirical statistics may look very different from the theoretical probability that is distributed in the entire population. Okay, and also what's the empirical probability of actually having a girlfriend, right? So how many of you actually have a girlfriend or boyfriend versus the probability, the theoretical probability of finding a girlfriend? So those are interesting numbers that you can collect from your customers, from your employees, or even from your companies and so on. But I want you to be able to distinguish, right? So you will get empirical data that may or may not agree with theoretical numbers. In a way, data analysis is very similar to yoga practice in some interesting ways. So I always like to talk about variables. So we're going to start to talk about variables. And I always like to talk about variables as yogis. They all are different in many, many different ways. Okay, so for example, every yogi has central tendency, which means they have a center. Okay, the variable, as you can see over here, has is pretty sort of balanced and symmetrical. And sometimes they're not, right? So this is not a very symmetrical shape, and it's like tilting towards one area versus others. We not only measure where the center is of your variable, okay? And this is a distribution, this is a shape. So we always, just like looking at yoga, you would pay a lot of attention to the shape of the pose. So we can talk about the shape. Is it symmetrical or not? We can talk about where the center is. We will also be talking about how spread out some of the variables are. So you will see variables are just like yogis. Some of them are very spread out and some of them are not. And we'll have a numeric way to quantify dispersion, quantify central tendency, and quantify the distributions. So I want you to have an overall picture. We'll talk about the details in the next lecture. But right now, I want you to keep in mind this yoga analogy, and we'll be referring to this quite a bit. So theoretical probability, it's sort of like what the yoga pose theoretic, like the perfect yoga pose that you're supposed to do. Okay, empirical statistics is what you actually get, which is the ugly truth. So sometimes it looks like the theoretical perfect pose, but a lot of times it does not, right? So the reality that we're dealing with, so, maybe theoretically there are a lot of, people who like chocolate, but the ugly truth is the small batch of customers we attract somehow hate chocolate, for example. So you may get empirical statistic in your sample that may or may not look like the theoretical probability. And this is why, in addition to theoretical numbers, we always need to do our own data collection, our own analysis to figure out what's really true with our particular sample. So we kind of talk about this. The theoretical probability of getting a woman randomly is 50%, but the reality is in our customer base, right? How many women do we have in our class, in our analyst sample? Do we actually have 50% women, or is it less than that, more than that, right? How does that differ from the general public? The theory, again, theoretical probability is what you would expect to see, and the empirical is the bloody reality, right? That doesn't always agree with the theoretical expectations. So we'll talk a lot about this, and a lot of research or a lot of data analysis is really about using empirical, what we observe in our sample, to estimate the theory, because the theoretical numbers are not always available. So we'll talk a lot about these examples. Again, just to kind of recap this very important distinction between theoretical probability versus statistics, you can see that the first one sort of illustrates the idea of probability, right? So you will have information in this bucket over here, and that the bucket represents the entire population. And if you already know, if you are God, for example, and you actually know what's in this bucket, every single marble, every single person, every single customer, every single company, exactly what's going on, how many of them are white, how many of them are black, how many of them are whatever shape, what's the probability of getting a black versus white versus gray marble. If you already know all that, you have access to every single marble in that bucket, then you will actually know the theoretical probability. So if I know exactly how many marbles there are, what kind of marbles there are in this bucket, then I'll be able to know before I even reach out into the bucket. If I reach out into the bucket and randomly draw a marble, I will be able to predict what kind of what's the probability that I'm going to get a white versus black marble, for example. Okay, so given theoretical probability, I'll be able to predict the likelihood, right? I will never be able to predict exactly what's going to happen, but I can predict what's the probability that something will happen. Now, most of us are not God. We don't always have access to theoretical probability. So the reality a lot of times is unknown. And so we will have to guesstimate. We don't have access to the exact content of this bucket, the green bucket at the bottom. So what we have to do instead is we only have what we have in hand. We drew a little bit, a few marbles from the bucket, and by looking at what we have in our hands, we can try to guesstimate what's in the green bucket. We may never know for sure, but we can estimate it. We can estimate how confident we can be. We can estimate maybe a range, right? But we'll never know precisely what's in the bucket. But we can try to use what's in the hand, which is our empirical statistics. It's an empirical number because it's just what actually we are observing. So the 5 or 6 marbles that we have in our hand that we drew out of the bucket, we can look at these marbles, analyze them. So data analysis is a lot of times it's analyzing the marbles in your hand and try to guesstimate what's in the green bucket. So again, probability is really about using the population to estimate, to predict what's going to happen with the sample, right? So if you have the theoretical probability that 50% of the population in the world like Reese's peanut butter cups and 50% of them like Kisses, then you'll be able to predict that if you pick a customer at random, what's the probability that that person will like Reese's versus Kisses, right? So you can use your theoretical probability to estimate exactly what's going to happen with the sample. However, this is very rare. Very rarely we will know the population exactly. So the bulk of this course, this data analysis course, will focus on inferential statistics, which is given the sample, we're trying to estimate the population. So for example, if empirically I have 3 kisses in a row, I can try to guesstimate how many Kisses versus Reese's peanut butter cups are in the green bucket. I'll probably never know for sure because I can't count. I don't have access to the entire population, but I can guesstimate based on what's in my hand. So why do we draw marbles using our hand? Why do we draw Kisses using our hand? Why don't we just look at the bucket? Well, it takes a lot of time to go through the entire population of the world or even the US, so it's very costly to study the population. So what we do, a more cost-effective way, is to just get a sample and study the sample and try to guess the population. And sometimes it's just impossible to access the entire population. It's not available to you. For example, if you're selling a new product, you're trying to do market research, it is impossible for you to access the entire population of your potential customers because you don't know who they are. So these are some of the questions that we can ask, right? So we can ask, do all customers like chocolate? How many of them like chocolate? So this is a question about the population. We'll probably never know because we'll never be able to access all of our customers. However, I can take a sample of our customers. So all the customers population, I don't even know, there are existing customers. There are also an unknown number of potential customers out there that I don't have access to. However, I do have access to 100 Mason or 150 Mason students. So I can look at that as my sample. I can ask them if they like chocolate, and then I can use that sample to guesstimate my population distribution. So again, this is sort of summary of everything that we've talked about so far. We have talked about the idea of a population, the idea of data as a sample. So the data you have at hand, or the empirical data, is always a sample that you've drawn from the population for the reason that we don't have access to the entire population. So we only take a subset of that, right? So this smaller circle within this larger population circle, this is where this is really just a portion of the population that we take out as a sample. We can study the sample, analyze the sample. That's what we call statistics. And using the statistic, we can make inferences. So inferential statistics is really about analyzing this small sample to make a guesstimate about the entire population. And again, this is because theoretical probability, a lot of our known parameters. If you have access to theoretical probabilities, you have these known parameters. But most of the time, these population parameters are unknown. We don't know the mean and standard deviation, or how many of these people actually like chocolate. We can't go through the entire population of the world and ask every single one, do you like chocolate? Do you like chocolate? So what we do is we just ask a few people, and using that small sample to guesstimate what's going on with the population. So hopefully by this time you have a good idea of probability versus statistics and population versus sample, and you've heard variable a bunch of times, so let's clarify what that means. What is a variable? By the way, I really like the art by Yayoi Kusama. She has a lot of polka dot designs and for her installation arts, and I think they are just wonderful beauties for us to enjoy for a data analysis class. So variables, okay? The key points about variables is that they vary, and they vary along a single dimension. So we want to make sure that our variables measure something as narrow as possible, so they only vary along a very specific dimension. So some of the variables that we can look at, for example, price, personality. People vary in terms of personality. Products vary in terms of price. Guinness. Do you like Guinness or not? People vary on that dimension. Performance of your employees. People vary in terms of their performance. Countries, they vary. People come from different countries, so you may have a variable called country to capture where your customers or your products come from. Do you like beer or not? How much do you like beer? That is also a dimension along which people can vary. KPIs, so companies can actually, or units, right? Business units can vary in terms of their KPI. Stocks or investments can vary in terms of their risk. So risk can be a variable. Volatility, right? So how much your stock price vary can be a variable. And competition, how much is it very competitive? Is it not very competitive? So industries vary in terms of how competitive they are. So we can also measure that as a variable. But we never use the word variable at work. You rarely hear variable. Variable sounds very nerdy, sounds like it's very academic. Only statisticians talk about variables. Why would I need to talk about variables as a business person? Well, variables are just disguised as other words in the business setting. So you will hear a lot about attribute, dimensions, metrics, parameters, features, KPIs, field, like a column or a field in a database. Sometimes they're called inputs, sometimes they're called outputs, sometimes they're called goals by the strategy people. Sometimes they're called predictors, sometimes they're called outcomes, factors, labels, or business drivers. Okay, so I would say that when you see these terminologies, you should know that they're really just a different way to talk about variables. The bottom line is when you look at something, you should ask the question of whether you can fit all the values in an Excel column. And if the values in that column vary, then you have a variable. So a very sort of simple and naive way to think about a variable, which I think is actually very useful, is to think about whether you can represent that idea as a column in Excel. And if you can do that, you can do that well, consistently, and the values, you don't have all the same answers, the values actually vary, down the rows, then you do have a variable. Okay. So usually we will put together a data table like this. Sometimes it's called a spreadsheet, sometimes it's called a data frame. But basically it's a table that has rows and columns, and the cases are always the rows and the variables are the columns. Okay, so the cases can be people like Claudia, Bryce, and Gilliam, but they can also be companies, Uber, GM, Deloitte. You can represent these units as rows, as cases. And then the variables are basically the columns that measure these cases, right, in some specific way. So is Claudia a veteran? Yes or no. Is Bryce a veteran? Yes or no. Is Gilliam a veteran? Yes or no. So these three individuals can vary in terms of their veteran status, and we can capture the yes and no answers in the cells over here, and that will make veteran a column. Okay, similarly, we can talk about the revenue of Uber, the revenue of GM, revenue of Deloitte. They all have different revenues, so but we can represent these numbers in a single column, so that makes revenue a variable. The reason why I have these yogi logos here is to remind you that every variable is like a yogi. They have different shapes, they have different poses, they have different spreads, they have different centers, and you can measure their height and weight and spread and shape in specific ways. And we can quantify those things, but they will all differ, right? So all these are different variables. We have a lot of diversity in our variables, and we'll have to treat them as individual yogis, and we'll have to always ask, what is the shape? What's the center? What's the spread of the variable I'm looking at? Okay, so because they can be different. So that's when we describe a variable, it's like how we describe a yogi. We describe their pose, their shape, and whether it's symmetrical or not. So we'll do the same thing with variables. Okay, so you will see there are lots and lots of different shapes, and we'll have to come up with a scientific and a consistent way to describe the differences among these yogis. So in this week, we really focus on describing one variable. We want to profile a variable. Sometimes it's called data profile. You're producing a data profile, or you're producing descriptive analytics. Okay, so we will practice how to describe a single variable. We don't look at the variables' relationships to each other, right? So you may have lots of variables, but we're looking at each variable as a unique individual, and we'll just describe the variable as it is without consideration of other variables. In future lectures, we'll start to mix variables together, but right now we need to make sure that we understand how to describe each variable separately on its own. Usually we describe variables in terms of their data type, central tendency, distribution, which is form and shape, and dispersion. Today we'll focus on type. In our next lecture, we'll talk about the other three. So what type of yogi is your variable? Okay, so there are many different types of yoga, but there are also many different types of variables, and we will talk about 4 different types on the course, focuses on 2, numeric and categorical. We'll spend some time talking about time variable as well. So data is usually what we call scale data or random data, random variables. Depending on the discipline that you're in. If you're in computer science, you will hear a lot of scalar. If you were in statistics, you would hear a lot of random variables. But basically, data is data. Lots of people from all sorts of disciplines use data. And the most important distinction you need to learn how to make is the difference between numeric versus categorical variables, because this distinction determines how you pick a graph, how you pick an analysis. Everything is driven by this distinction. So let's make sure that we can tell numeric from categorical variables. So on the left-hand side, you see examples of categorical variables, and on the right-hand side, you will see numbers. Okay, so for example, if we are talking about color, we may be talking about black versus white. When we talk about gender, we talk about male versus female. When we talk about nationality, we talk about Chinese versus Italian. These are all what we call categorical variables. So one is not better than the other or bigger than the other, right? They're just different. So black is not necessarily superior or more inferior to white. They're just different. Male is not more superior or bigger or greater than female. They're just different categories. Chinese is not better in any particular way or greater or larger than Italian. They're, again, two different things. Big versus small, young versus old, healthcare versus sports. So industry is a categorical variable, yes or no. So that's the most common type of categorical variable. Sell versus buy, country versus pop music. When we look at numbers, the numbers actually carry those quantitative ideas, like which one is bigger, right? So if you look at a number variable that has 1, 2, 3, 4, 5, 6, 7, then 7 is definitely bigger than 1. And 4 is actually twice as big as 2. And if you add 2 and 3 together, you actually get 5. Okay, so you can actually do mathematics or arithmetic with these numbers, and numbers do carry a very, very distinctive notion of who is greater. Okay, so that's a very important thing to remember, that numeric values have this sort of size and volume and greatness associated with it. It's on a scale, versus categorical variables are usually, they're different, so different colors, different categories, but they don't necessarily always have a scale with the notion of some are bigger than others, right? So other numbers we can look at: 6'2", 180 pounds, 29 years old, $499, 79%, negative decimal values, 0.75, a trillion, so that's a very large number. You can also have very small numbers, and 6 gigabyte. These are all numbers that vary, and some of them are whole numbers, integers, some of them have decimal values, and they all also vary in terms of your units, right? So pound, foot, so the unit will actually vary quite a bit, but they all have numeric values. Categorical variables, like we talked about, the ones that are unordered, so they don't really have a scale. This is what we call nominal. So these categories have names. Nominal meaning that they have names, they have labels, but they don't really come in a particular order. So green, red, blue, green is not greater than red, red is not greater than blue. They don't have to be in this particular order. That you can present them in any order. They're equal in terms of their status. They're just different labels. Okay, but you also can have ordinal categories. They are actually ordered. Okay, so some categories are greater, more significant than others. So for example, you may often see a Likert scale like this and survey questions, not at all, sometimes, and always. So these are labels, they're words, and we have 3 different categories for you to choose from. But we know that always is greater than sometimes, and sometimes it's greater than not at all. So this is actually 3 categories that are actually ordered in size in some way. Numbers can also be numeric variables. There are 2 different types. You can talk about the intervals versus the ratios. The intervals, for example, IQ and degrees Fahrenheit, they are on a particular scale that can go through 0. But 0 does not actually mean the mathematical 0. So for example, 0 degree of temperature does not mean that there's no temperature. Okay, 0 degree Fahrenheit versus, what's the other one? I can't remember. I can't believe I don't remember. But, 0 degree of temperature does not mean that you do not have any temperature. It just happens to be a number on the scale. Whereas if you have a ratio data, 0 actually means the mathematical 0, meaning there's nothing going on. Okay, so you can also, for the ratio kind of data, you will also have discrete versus continuous numbers. So discrete numbers are counts, right? 1, 2, 3, 4, 5. When you're counting the number of animals and the number of people, you cannot have decimal values. Whereas continuous variables have decimal values. They're bounded. Sometimes they're bounded at 0. Sometimes they're not bounded at 0. So these are all sort of fine differences in variables. So we'll talk about later. Counts can also happen without time frame, but sometimes you have to count things within a particular time frame or a particular location. Then that kind of numeric variable has a very distinct distribution called Poisson distribution. Again, this is beyond this lecture, but I just want to mention these words so that later on. These are all sort of ideas and concepts that will come back in later lectures. And the distinction between categorical versus numeric variable is I try to make it as clear as possible, but sometimes it's not so black and white. For example, age, very, very simple and very common variable. Is it numeric or categorical? In fact, it can be both. And it really depends on how you collect the data and how you want to treat it. Do you want to treat it as a numeric variable, or do you want to treat it as a categorical variable? Okay, so you can treat age as a number, which is 1, 2, 3, 4, 5, right? And you can actually have decimal values. You can decide, actually, do you want it to be discrete, or do you want the age to allow decimal values, which makes it a continuous variable? Okay. Categorical variable, you can also treat age as age brackets. So instead of talking about 18 or 18.5, we can talk about the category of people, right? Those who are under 18, those who are between 18 and 25, those who are 26 to 45, and so on and so forth. In fact, you probably have heard of Gen X and Gen Y or the millennials. Those are actually age categories, right? Instead of in generations rather than a specific number. So again, age can be construed as a numeric versus categorical variable. That really all depends on how you want to do your analysis, what's relevant for your research question. And you actually have a lot of decision to make and a lot of power to determine whether you want to do numeric versus categorical. You can actually convert them back and forth. So there's a lot of things that you can play with this. Okay. So again, I want to show you a lot of the nuances and actually a lot of decisions you will have to make as a data analyst. So a little bit of a quiz, right? So take a moment to look at this and see if you can determine whether these variables are numeric or categorical. Okay, so I want you to just kind of take a look at this, think about it, and maybe have a little bit of discussion. Let me know what you think. And if you have these categorical variables, right? Veteran, gender, like peanuts, country, do you want to treat them as an ordinal variable or a nominal variable? A very particular type of categorical variable is called binary variable. So nominal data can be binary. And we'll see a lot of binary data in our examples and exercises. Binary data are very, very common in business world. Categorical variables are extremely common. They run the world in the corporate world. So you have to get used to a lot of categorical variable. And a very simple thing is binary. So we just want to know the presence versus absence of something, and the two pieces add up to a whole pie. Okay, so this is another, again, I think we've seen this in the summer probability series, but this is a teacher that says there are two types of people in the world. So two types, meaning it's a categorical variable. The first one is those who can extrapolate from incomplete data. And then number two is missing. So here it says, well, so two of my classmates just asked our professor if his shirt is missing a second part. Well, why is this funny or silly? It's because you really probably belong in that second category, which is those who cannot extrapolate from incomplete data, right? So again, this just shows you that if you have a binary variable, basically there are only two categories. Those who can extrapolate, and then the other half is basically the opposite of that, which is those who cannot extrapolate. In prediction markets, in business world, I mean, prediction market is just one of the many examples. We see a lot of binary events, okay? Will Trump win the event, the election, or will Trump lose the election? Those are binary decisions. Should I buy or sell this investment? Again, a very simple but very important binary decision that you have to make as a manager. Okay. When you look at numeric variables, take a look at these and decide if they're continuous, discrete, or count. Again, I want you to think about this and sort of come to a decision on your own. And keep in mind that sometimes it can be any of these, and it really depends on, it's up to you as a researcher. Sometimes you don't have a choice. So number of bedrooms, for example, should be discrete. You don't have half bedrooms, right? 0.7 bedrooms, or, so it should be a discrete count, right? You basically count the number of bedrooms. But sometimes it's kind of up to you. For example, mileage, right? So you can make it continuous, you can make it discrete, and you can even make it count. So it really depends on what you want to accomplish. So you have a lot of choices. Time variable. So in business, we look at a lot of dates. In accounting, transaction data are all time-based. The stock prices are all time-based. Yearly, quarterly earnings are all time-based data, right? So monthly sales, what happens in a millisecond, these are all sort of time variables at different scales. And these are actually very common, and we would use time for a very particular type of analysis called time series. So let's practice describing one variable in JASP. So once you get your data set into JASP, you should look for this button called Descriptives. And this very easy button will allow you to do all sorts of descriptions of the single variable that you choose. So let's take a look at that. So this is the descriptives. Once you click this, you can choose descriptive statistics, and then you'll get a list of all the columns are now listed as rows over here. So you can choose a column. For example, I like chocolate. I know that's a number. Then I can just put it over here, and then I will get a descriptive statistics table here very quickly. I can see how many cases there are, 110, nothing is missing. I can see the mean, standard deviation. We'll talk about what these are in our next lecture. You can also generate plots. A very important way to describe a numeric variable, so keep in mind this is a numeric variable. You will get a histogram like this. So you can come down here and check distribution plots and get a very nice histogram. Again, we'll talk about what this is in our next lecture. We can also look at describing a categorical variable, although I'm from outside Virginia. I'm from Virginia, right? So that's a categorical variable. So you can generate a plot, but you're probably not going to get a table like this because we do not talk about mean and standard deviation for categorical variables. I can ask for a frequency table for the categorical variable, and so I get a list of the 1, 2, 3, 4, 5. I also get the outside of Virginia versus Virginia, so you can get these numbers very nicely. You can also do that under frequencies. You can also do frequency under this menu, but that involves 2 categorical variables, so we'll save this for later lectures. Okay, so basically you can practice describing a number, and you can also practice describing a categorical variable. So I would encourage you to try these different variables. Again, I am having multiple variables on this chart. Okay, I've chosen 3, but it's very important to keep in mind that I'm not describing the relationship among these variables. I'm actually describing each variable by itself individually. So I'm still describing a single variable. So this is describing a single variable, which is a column. Enter accuracy here, right? So that's accuracy. This is the single variable about where our student is from. This is a single variable about whether the student liked chocolate or not. So we're describing these 3 variables separately, individually, as single variables. There's also a category of variable called unstructured data. So for example, text. In our survey, I asked for favorite industries, favorite hobbies. Those are open-ended questions. You can enter whatever you want. So that's text data. Customer reviews so the stars are actually quantitative data. However, the review over here is qualitative data or unstructured data or text. That can be analyzed, but we are not going to talk about how to analyze that in this course. Tweets, for example, these are very commonly available unstructured data that we get all the time. So this course is focused on structured data, numeric, categorical, and time. The unstructured data, text, images, and videos are beyond the scope of this course. You can take additional courses on these if you're interested. So what did we learn today? We learned about the distinction of probability versus statistics, population versus sample, what is a variable, the 2 different data types, numeric versus categorical, how to distinguish them, the time variable, and what's unstructured data. So hopefully you are able to see the distinctions and to be able to recognize these very clearly after today's lecture. Thank you very much. We'll see you next time.